7.3 notes. All right. Yeah, I did. Sophia did.
I raised my hand.
It's Women's History. Oh, yes. Every month is Men's History Month. What's that? You're asking me something. All right. These notes are actually kind of hard today, so be careful. We good?
I'm passing out the notes.
All right. So, non-calculator quiz Tuesday. All right. Today we're going to talk more about simplifying radicals. Okay. So I'm trying to think. So this first page of notes is pretty straightforward. You kind of just do the same thing over and over again. Second page gets a little tough. Second page there's some curveballs there. Some curveballs. All right. Any baseball people in here? All right. Spin rate. Spin rate at the back's really high. All right. Backside is spider tag. All right. So you gotta be careful. And be careful on the back page. So what I'm going to do, the first page, I'm basically just showing you different tools you have for doing the back page, okay? All right, number one. First thing you can do is you can combine radicals. You can combine radicals. Okay? Notice I use the word radical and not just root because not every single radical is a square root. So people got confused. Right? This is a radical, this is a square root, it's also a radical. This is a radical, it's not a square root, right? The radical is a little check mark symbol. Anytime you see that symbol with like a 1 or a 2 or a 3 or a 4, that's what I mean by radical, okay? Little check mark symbol, okay? So you can just combine these into one. So the square root of 5 times the square root of 2, that can just combine into one giant square root. Square root of 5 times 2, which is the square root of 10.
And that's just that?
Yeah. Okay. B. The cube root of 7 times the cube root of 9. Right? We can just combine that into one big happy cube root. And cube root, yeah, there you go. 63. 7 times 9 is 63. Okay. C. Yeah, it's fine. Yeah, we're just multiplying right for now. I don't think that can be simplified anyway. All right, this one, we can just combine everything into one big happy square root symbol. Just a little bit of a cough. We'll see what happens tonight if I get sick.
Would you still have to test on Tuesday regardless of whether or not you're sick that day?
Yeah, because I don't have any more. So. Please pray for my health. What's that? No, I don't. No, but I'm like really nervous. It's gonna hit me. It's gonna hit me at 3 a.m. All right, D. All right, we combine everything into one big happy fourth root symbol. That's what all the other teachers I've been talking to have gotten. They're like, it just hit me. Like, I thought I was included. It just hit me.
Mr. Rushton,
Yeah.
I'll be praying for you at 3 a.m.
You're going to be able to do it.
I'm going to send one. Mr. Rushton, I'll send you an email at 3 a.m.
Could just like put like set like an automated like program Gmail to send an email.
Is that possible?
Yeah.
No, but this is not the same.
It's just not the same as doing it live. We'll do it live.
If we do it live, we're going to be dead for school on Friday.
You seen that, Bill O'Reilly? No.
I have no idea.
No, go on YouTube without your parents' permission. Okay, so yeah, that's how we do the first four.
Wait, did you say look up on YouTube without our parents?
I said don't go on YouTube without your parents' permission. Okay, number 2, the second thing, there's another strategy we have to use. Okay? And this strategy is we can, when we're looking at fractions and multiplication, we can split up our radicals. So also try splitting your radicals. Sometimes that helps.
So it's been radical 9 and radical 64.
Yeah, so sometimes it's easiest just to split these up and give every single number its own square root symbol. Okay? It's easier to do the square root of 9, 3, over the square root of 64, 8, than it is to do the square root of 9 64ths. Right? If I saw you in the hallway and I said, what's the square root of 9 64ths? You'd be like, what? And if I said, what's the square root of 9? You'd probably just say 3. Okay? I don't know why I find that so funny.
Do you have to have a square root sign over it?
What's that?
Do you have to put a square root?
If you can just jump from this step to this step in your head, that's fine too. Just get the right answer. Yeah, I'm doing a lot of things today that people can probably do in their head, but not everyone can. So I'm writing them all down. All right, B. All right. So we're going to split this up and give every number its own fourth root symbol. Okay, can't simplify the top. Okay, so this is going to be fourth root of x over, what's the fourth root of 16? 2. All right, if you're having trouble doing that in your head, honestly, just guess and check. Okay, so think to yourself, what number times itself 4 times gives me 16? Just go through. All right, let's try 1. 1 times 1 times 1 times 1 equals 1. That's not 16, so that doesn't work. Okay, let's try 2. 2 times 2 times 2 times 2 is 16, so that's my answer. Okay. All right, and then to do this, how do I simplify this guy right here? So here's what we're going to be doing. So I'm going to highlight this in pink, the inside number in pink. I'm going to highlight the outside number in orange. You're going to divide the inside by the outside. So it becomes y to the 1. Okay.
That's why.
Do you have to?
Yeah.
Do we have to vote for one?
No.
You do.
Yeah, I do. Oh, wait. Oh.
Yeah.
All right. C, right? I'm going to split it up, give every number its very own cube root symbol. Sorry, jumping ahead of myself. Okay, cube root of 2 does not simplify. What's the cube root of 8? 2. And then how do I simplify x to the 9th cube rooted? So, right, so it's going to be x to the 9 divided by 3, which is 3.
Divide in this over out.
Yeah. All right, is that okay? Some people are still writing. I'll take a sip of water. I'm just going to hit the gym today, but my pre-cal kids need a review video, so.
Maybe you should have a chip.
Why don't you do this breakout video after the
You're
gym?
making it
You're right. You know what?
First you think you're sick, now that.
Yeah, you're right.
You need to get one more workout in if you're going to be sick.
You're right. Yeah, I'm not going to make my review video.
Or,
Yeah.
you make it gym related and you film it while you're at the gym.
Mr. Rushing, what do you listen to at the gym? I'm honestly-
I'll tell you later. There's a long story, actually. Long story.
Odds are it's like today's night.
I gave up music for Lent, so I have to listen only to uplifting music. Yeah, all right. So I've been listening to just like classical music. I'm only supposed to listen to music that lifts the soul to God. And so it's praise and worship. It's either praise and worship or classical, so I chose classical. What's that?
Oh, I thought you were lifting like off.
I could do that, I guess.
Mr. Ruska, are you serious?
Yeah.
Wait, you're listening
Usually it's like Taylor Swift or something. Like when it's not like.
Yeah.
We found
Oh, that's right.
We found this one.
But you found mine?
Yeah, the page did.
That's hilarious. All right. When, hers? Lover. Lover. All right. When there's nothing in the square root symbol here, what number technically is there?
2.
2. Okay. How do I simplify x to the 12th square rooted then? X to the 6, right? Because 12 divided by 2 is 6. Square root of 25 is 5. Y to the 8th, right? 8 divided by 2 is 4.
It's just for.
Why did I pull out? What, I put the 2 there? Well, I just wrote it because if you know in your head that like taking the square root you divide by 2, that's fine. I just wrote it there so people know that like if you're taking the square root, there's an implicit 2 here that they don't ever write. Right? That helps some people remember that like the square root of y to the 8th is 8 divided by 2. That's why I wrote it there. I don't have to. Again, I preface. If you can do any of these like instantly in your head, just do them instantly in your head. Okay? I'm just writing all the steps out. Okay. All right, E. There's a little negative symbol there. Just copy that down. It's outside, so you don't have to worry about it. Right, and then that 125 is going to get its very own cube root symbol. The x is going to get its very own cube root symbol. The y to the 9th gets its own cube root symbol. And so I'm splitting up the radical. What's the cube root of 125? 5. And then what's y to the 9th cube rooted? Y to the 3rd. Y to the 3rd. So there you go. There you have it. For the first page, now it gets kind of tough. All right, so we talked about we can combine radicals. We can split our radicals up. Now I'm going to show you how to simplify numbers, okay? So how do I want to say this? Another trick is simplify big numbers by doing, do you guys know what I mean by prime factorization? Okay, do you guys know what I mean by Christmas trees?
Is that like
That's
Are they like
Yeah. Okay, by doing Christmas trees.
this one did not teach me.
All right.
She used to eat. No, it's not true. She loves Sophia. She loves Sophia.
All right, so I can rewrite 20, right, as, let's split this up, okay? 2 times 10. Whenever you see a prime number, just circle it, okay? You say 2 radical 5. Okay. All right, again, if you can do this in your head, just hold tight.
She threw something.
All right? So I can rewrite the square root of 20 as the square root of 2 squared times 5. Okay?
You can't pull the 2 out.
You can't, I'm just doing an absurd number of steps for people who are
Okay. I was just
Right.
like,
And that's the same thing as the square root. Okay, let's quiet down a little bit. The square root of 2 squared times the square root of 5. Right, I can always split them up. What's the square root of 2 squared? 2.
You just done 4.
Yeah, if you can do any of these instantly in your head, just do that. I'm doing a certain number of steps for people who have trouble.
I don't like it either, but like I had like.
Did you get that answer immediately? Yeah, again, for like the 8th time. If you can do these instantly in your head, that's awesome. Just ignore what I'm doing, or they get hard. No, you don't get a calculator. All right, yeah, like, can you guys do that one instantly in your head? There you go, okay, so I'm going to break it up. So I'm going to break up 48. 48 is 2 times 24, which is 2 times 12, which is 2 times 6, which is 2 times 3. So I have 3 and 4 2's. Okay? So I can rewrite the square root of 48 as the square root of 2 to the 4th times 3. Fun. Okay? Let's break that up, okay? So that becomes the square root of 2 to the 4th times the square root of 3, right? We can always break up our radicals. Right? What's the square root of 2 to the 4th? It's 2 to the 4 over 2, right? So 2 squared versus 4. Okay. Do you do that in your head instantly? Awesome. Yeah. Why, there's a 4? So, right, so that 2 to the 4th square root, that becomes, right, we divide the exponent. Yeah.
What do we do if this is a variable?
I'm about to tell you. Like this one. Yeah, so if there's a variable, break it up. Give it its very own square root symbol. Break it up. Okay, what's the square root of 16? The square root of x squared. X. What? The Irish blessings? Oh, like, I've had a cough. I really hope I don't have like a cough and a stomach bug at the same time. I'd be pretty sad if that happened. I'd be pretty dejected, not gonna lie. I'd be seriously rethinking my life. All right, I gotta stop talking. I'm just like running my mouth at this point. All right, D. All right. If there's a lot going on, just break it up. Okay. Just break up. Okay. Square root of 16, right? Easy money. It's 4. Square root of x cubed. Run into a little problem there, right? What's going on? You can't do 3 divided by 2, can you? No. So here's what we're going to do. Not going to turn into a fraction, unless our directions say to leave it in fraction form, but they don't here. What do we do? So 3 divided by 2. So we are going to divide it. This is going to give me what? How many times does 2 go into 3? And what's my remainder? 1. Okay? So what I do, since my answer was 1, next to my 4 I'm going to write an x to the 1. Okay? And because my remainder was 1, I'm going to have a square root of x to the 1 left over. Okay?
So we do 4x square root x?
Yeah, that's it. 4x root x.
Is that right?
Yeah.
And that's more simplified than 16 actually, right?
What's that?
That's more simplified than 16.
Yeah. Oh, yeah. Mathematicians do not like irrational numbers. Therefore, when they see a radical symbol, they try to pull as many numbers out of it as they can. So, E, right? E's the same way. There's a lot going on there. What do you do when there's a lot going on? Break it up. So it becomes the square root of 90 times the square root of x to the 7th times the square root of y to the 8th. There you go. Okay, let's do this one at a time. So I'm going to label this with colors. Okay, square root of 90, that's a big number. Does anyone know off the top of their head that that equals 3 root 10? No. So what do we do to break up a big number? There you go, yeah, a little Christmas tree action, okay? So that's the same as 9 times 10, 3 times 3, 2 times 5. Okay? So the square root of 90 becomes the square root of 3 squared times 2 times 5, and I can break that up too. Square root of 3 squared times root 2 times root 5. Okay? What's the square root of 3 squared? Just 3. And then I can't simplify these other two, so I'm just going to combine them. Okay? So that's the green part. Oh, excuse me. Square root of x to the 7th. How do I do that? So 7 divided by 2, right? That gives me what? Gives me 3 with a remainder of what? 1. So that's going to be x cubed outside the square root, and then x to the 1 inside the square root. Okay? So that's that guy simplified. And then what does the orange part give me?
Y to the fourth.
Y to the 4th. Okay? So let's multiply everything that's outside our square root together. So 3x cubed and y to the 4th. So that's 3x cubed y to the 4th. And then everything inside the square root is going to go together. That's my answer. There's a white highlighter on here. That's interesting. Can't really see it though.
Those are whites. What? Why is there a white highlighter?
I don't know. What? Hundo P. Yeah. Yeah. Yes. Like 100%. All right. Who knows off the top of their head that that this is 3 cube root 2? All right. Well, Sophia does. Not everyone does though. So I'm taking this 54, and I'm going to break it up with my Christmas tree. 9 times 6. Okay, so I did the prime factorization of 54, I did the Christmas tree thing. So I can rewrite the cube root of 54 as the cube root of 3 cubed times 3. Right? Let's break it up. Cube root of 3 cubed times the cube root of 2. Be careful. These are not square root symbols. These are cube root symbols. All right? So what's the cube root of 3 cubed? Right? The 3 divided by 3 just gives me 3 to the 1, or 3. And then I can't simplify the other one. That's my answer. Blue and gray. Alright, you okay? Whoa, open that up. Oh, who did?
Mr. Rusher, you're just being a nuisance.
Stop teaching math. All right, G. How do I do G? Yeah, so 4 divided by 3 gives me 1 with a remainder of 1. Okay, so that's x to the 1 on the outside, and then a cube root of x to the 1. One little thing I should note is whatever they give you in the problem, whatever type of radical symbol they give you, so I have a cube root here, that's going to be the symbol that's in your answer. Okay? Some people had a question about that. And that's the answer to that question. Okay? All right. Good stuff. H, kind of a lot going on there. What are we doing? There's a lot going on. Break it up. There you go. Okay, so cube root of negative 24.
Doesn't that give us an imaginary number?
No, it's a cube root. So if you're doing a negative and there's like an odd number here, you're going to get a negative, just a negative number. Yeah, so let's break that up. All right. So let's break up 24. 24 is 4 times 6, 2 times 2, 2 times 3. So this gives me the cube root of negative 2 cubed times 3, or the cube root of negative 2 cubed times cube root of 3. And again, right, if there's a negative 2 underneath a square root, that would be imaginary, right? But you can take odd roots. You can take odd roots of a negative. So that gives me what? Negative 2 times cube root of 3. So we broke down the number. What about this guy right here? What does that become?
Be 2 with the remainder of 2.
Yeah. So 8 divided by 3 gives us 2 with a remainder of 2. Is there a question? What's up here? A question? Yeah, sorry. So the x cubed to the root to the third becomes x squared times x squared inside the cube. And then what's 10 divided by 3? What is that? 3 with the remainder of 1. This becomes y cubed times the cube root. Alright, so our final answer, we're just going to multiply together everything that's on the outside. Alright. And then multiply together everything that's still stuck inside cube root symbols. Cube root of 3x squared y.
Why is it y?
It should be, thank you. That's an error. Thank you, sorry about that. Just testing you. Nice. Let's do I. Let's do I. There's a lot going on here. Alright, let's break it up. So fifth root of negative 32 times fifth root of x to the fourth times fifth root of y to the 10. Actually, this one's not too bad. What's the fifth root of negative 32? Close. Negative 2. Yeah, if you're doing an odd root of a negative number, your answer is going to be odd. What's that? Yeah, so I do that off the top of my head, but if you didn't, you can always break it up with the Christmas tree. So you'll actually get like 5 2s if you do this, and then you'll get fifth root of negative 2 to the fifth. And that just cancels. Very good question. What about this guy right here? What happens with this? Can I do 4 divided by 5?
Nope.
Yeah, so 5 does not go into 4 at all, so I'm just going to leave that. That guy's fully simplified. Okay? And then what's y to the 10 rooted to the 5th? Yeah.
How is that fully
What? It just be 0. It's 0 for a remainder of 4. You can't do 4 divided by 5. It's big. 5 does not go into 4 at all. So if you did that, technically it's 0 remainder 4. So you get x to the 0 times x to the 4th. X to the 0 is just 1, so it just becomes that again. Alright. Yeah, so our answer is this. Y 10, right? So what's 10 divided by 5? With a remainder of 0, right? Which became 1 squared. Good question. All right, we're almost done. last step, this is another example of just sometimes it's a good idea to combine your radicals. All right, so we're going to combine our radicals and then we're going to divide. Then simplify. Okay, so those are like the 4 big tools we talked about today. Okay, I guess 6 if you talk about like the Christmas tree stuff and like the dividing the inside number by the outside number. Okay. So let's combine our radicals. So square root of 80 over square root of 4. You can do that, right? You can do them separately. It's easier if you just write it as one big radical first. Becomes square root of 20, which is 2 root 5. Right, we did that up above. I have given you the tools you need to prosper.
Wait, how is it easy to do 80 divide? Oh, did you just divide 80 divided by 4?
Yeah.
So that's 80.
Then doing the square root of 80.
So
Can I do K? This is another very good example, right? Who knows the cube root of 81 off the top of their head?
Oh, wait.
No, it's not. Who knows the cube root of 3 off the top of their head?
1.
No, it's not.
It's not 1?
It's irrational. It's decimal. All right, but who does know the cube root of 81 over 3 off the top of their head? What's 81 divided by 3? 7. What's the cube root of 27?
3.
If you're having trouble doing that in your head, just think to yourself, what number times itself 3 times gives me 27? 1 times 1 times 1? 1, no, okay. 2 times 2 times 2, 8, okay. 3 times 3 times 3, 27. Okay. Remember that? Elementary school teacher? You ever play like around the world in elementary school? Like, what's 9 times 3? What's 4 times 5? 20. I was so good at those.
So,
I literally do not remember that at all.
I started crying.
Yeah, it's stressful. Super stressful. Me and my best friend were so competitive with each other.
Did you go 50-50 or no?
No, we went like 80-20. Come on, man. Do you know me? No, I'm kidding.
I mean, I do know you. I was like, you went to Georgetown trying to go into like
All right, guys.
Never gonna get it.
All right, this is a lot easier if we divide first.
I know I am. It's Russia. I got another same guy. I got another.
X to the 7th y cubed divided by xy. How do we do that? Remember? These technically have 1s on them. What do we do? Yeah, so we subtract the exponents when we're dividing, right? Square root of x to the 6th. Square root of y squared. Let's break it up, right? Let's break it up. Do it one at a time. Square root of x to the 6th times square root of y squared. And what's the square root of x to the 6th of the x cubed? What's the square root of y squared? Okay. All right. Okay. Can I move on to M? Really complicated if we try to do them separately, right? Gets a lot easier if we combine them into one giant radical. Right, gets a lot easier. Right? What do I get when I do that division? So 40 divided by 5 is what? All right, x to the 5th over x squared. Good, and then y to the 9th. Okay, then we can break them up. Okay, again, at this point you might be able to just break them up and do them all in your head at once. That's awesome. All right. If not, you can always just break them up. So 2x and y cubed. Yeah. All right, n. All right. Ooh, we actually haven't gotten this far all day, so first time I've looked at this problem. Here's what I'm going to do. Okay. I'm going to combine just this part, which you can do. I'm going to combine just the stuff I just highlighted in pink. So that's going to give me what? Square root of 50x squared over 25x to the negative 2. And then there's just going to be a negative 1/5 out here. Okay.
Doesn't this become square root of 2?
On the inside?
Yeah.
Haven't gotten that far yet. All right, and then on the inside just becomes square root of 2. Sorry. Okay, so what's 50 divided by 25? 2. And then what do I do with this x to the negative 2?
X to the fourth.
Move it to the top, it becomes x to the 4th. Okay. So that gives me negative 1/5 times the square root of 2 times the square root of x to the 4th. Okay, so negative 1/5 x squared root 2.
Yeah.
How do I get rid of the x to the 4? What's the square root of x? Yeah, there you go. Yeah, there you go. You want to ask me too why I wrote it. Ben, you have a lanyard? You got 8 more minutes. You with your lanyards.
Do you like that style lanyard better, the style that teachers are technically allowed to have, where it's like connected to like your belt?
Oh yeah, I feel like that's cheating. I feel like the teachers have to wear it too. In solidarity.
Yeah,
In solidarity. It's not that good. All right. This one, right? Who knows the 5th root of 729 off the top of their head? That's right. No one does. What'd you say?
27.
Wait, really? No, that's way bigger than 729.
for sure.
Yeah. You guys know that?
Yeah, $5.
27 to the 5th is way bigger than 729.
13.
No, 7.
13 to the 5th is still way bigger than 729. Yeah.
We all get a hundred on that next
If I had to guess, I'd guess that it's 3. Someone check me. Someone.
3 to the 5th.
No, 729 square.
Yeah.
What?
You got it.
It's 3.
I got it? Yeah, let's go. All right, so I'm going to combine these into one giant square root. I'm really good at estimating. I'm like always the guy that wins, like the guess how many M&Ms in the jar. I always win those.
But how do you win those?
Because I can just tell, I can just look at it and I'll be like, it looks like there's like 200 some. I don't know. 215. All right, 729 divided by 3 is 243. I'll be honest, this one I kind of question whether it can be done in your head. What's that?
Is that because you know how to do it?
No, I said I question whether it can be done. So like, because I don't know how to do it in my head.
So I think that's the first.
Yeah, 243. Hey, I got 729 fifth rooted in my head. That's pretty sick. All right. So let's break it up.
Yeah. Okay.
Everybody's got their thing.
That's so mean. What?
It's true. No, it's not mean. It's just true. My thing is math.
Oh, bad.
It's not math. Okay, 243. Let's break that down. That's 81 times 3. That's 27 times 3.
What are they?
So this is fifth root of 3 to the 5th. Times, yeah, take care. Times x. What does x to the 7th root to the 5th become? What does this become in the middle?
Does it become 1 root 1 remainder 2?
Yeah. So we get x, y squared, wait no. we get 3xy squared, right? This just becomes 3.
Yeah.
3xy squared. All right, so here's the homework. I'll you copy that down. Homework for tomorrow, or for Monday.
Wait, why is it still x this time? It should be x.
Sorry, it should be x to the squared, sorry. Hey, we got through everything. We didn't do that in the other 2 classes. All right.